Alright, hi guys, welcome to today's day 8 version, Programming ZKP part 1. So I'm going to be using this website. This is from Oscar. He created a new website. It's called ZK Intro. It has 3 main articles. It's very useful, it's an amazing. And I'm going to be talking about this Programming ZKP from zero to hero. So this is the website itself. This is how it's actually, the domain is zkintro.com. And the first one is a friendly introduction to zero knowledge. This is really beginner friendly, clearly written. It's going to be explained about ZKP, and then he's programming ZKP from zero to hero. So we're going to be programming the main ZKP mainly in Grow 16. So this is really good start. So and then there is another articles about understanding the math behind ZKPs, but we're going to be covering in the next videos. I'm going to be sharing all the learnings, but today the main topic is going to be this. So what is the ZKP? ZKP is technically, it might have pre-processing step or not, but there's a problem, and then we're gonna use arithmetization to arithmetize this, and then we're gonna use polycommitment schemes to make it verifiable in a big scale. And then let's say in this example we are using Grow 16, and how this is gonna happen? We're gonna have pre-processing step. We are gonna be creating trusted setup, and we're going to be having arithmetization. So we are going to be writing the circuit. We're going to write the circuit in the circom. It's a specific language for that. And we're going to be building the circom. And while building, it's going to create 2 files. One is R1CS. This is the binary file for describing the circuit. And another file is WASM. This is to create the witness. And we're going to be generating proof. We're going to use input. So we have these inputs. We're going to have witness and proving keys. And at the end, we're going to be verifying. Let's check it out. Actually, if you check this website out, it is clearly explaining everything from the start. So we are going to be creating, this at the end, signing group messages. So by that, but this is at the end, I'm going to be covering the first iteration part. So there is a specific GitHub repo for that. You can check it out yourself. You can exercise, you can learn from that. So this is what we are creating here. Template, multiplier, 2. So we're going to be taking 2 inputs. We're going to multiply them. We're going to output into another node or another output. So here on on. First of all, we're going to be writing the circuit, and then we are going to be creating we're going to be building the circuits. It's going to create R1CS and WASM files, and then we're going to be creating a trusted setup. So it's going to create proving keys and verifying keys, and here we are using in the example, it's going to create, this is the file name is going to be, and then we are going to be generating proof. So we are going to be using this proving key input JSON. This is which are our inputs, and example 1 WASM. This is the in order to create the witness, and at the end it's going to create proof and public outputs. So here is the proof, and it's going to create the public output, and at the end we're going to be verifying it. So this is the end of part 1, iteration 1. I'm going to be showing how we are going to be doing this, because I've already prepared the stuff. So I'm going to be changing my window capture into where is my terminal? So okay, I think my terminal is visible now. So that's good. I have already cloned it. I have installed all the dependencies necessary. You can check it out in tutorials given. So we're going to be starting first. So I'm going to show these files, and we have our example 1 is the circuit circum is in the example 1. So we're going to go into example 1. We have a lot, so I'm going to show example 1 circuit. So this is the circuit, and it is correct. Oh, we have the one error right here, so we're going to be editing this. Okay, example 1 circum. Let's edit it. It should not have 3, it should have 2. Okay, that should be done. We're going to be saving it, and let's build it. We are using build tool, so just build example one. Okay, here it's built. We have everything is here, it's given, everything is okay, written successfully. We have R1CS and we have example one wasm, everything's ready there. All right, now we are gonna create trusted setup. We're gonna have trusted setup ceremony. So just trusted setup example one. Oops, I think we wrote something wrong. Just file. What should we write? Trusted setup. Oh, trusted here. Trusted setup example. All right. So we had a mistake. It should be with underscore. Here we are creating a trusted setup ceremony. It's asking random number. I'm just gonna random. It doesn't matter. It's just random number. I have to keep this safe. I mean, I should not share to anyone else. If we are using a group trusted setup, if everyone is also inputting their random number, and then if no one is sharing it, so that it will be safe, because now I'm sharing it. I mean, I know it myself, it doesn't really make sense, but if there are two people and if they are keeping it to themselves, I mean, at least one of them is keeping it to themselves, so it will be truly random. Otherwise, people can find out. It is taking some time. Okay, now it's the second one. Here it is. It's ready. We have created our verification key JSON and then example one ZK. This is the proving key. We have our trusted setup and we have the build, and then we are gonna just generate proof. So just generate. Okay, I forgot again, because you can check it out, the just file, all the commands are here given. So we need to generate proof, and then we need to verify. Okay, just generate proof example one. We are generating proof. Here it is, the proof is here, public is out as well. We can check it out how the proof is gonna look like. For example, I can cat example one target and proof. Okay, this is how the proof is gonna look like. This is how gross 16 proof is gonna look like. It has A, B, C, 3 elliptic curve points, and then the protocol and the curve. We are using BN1 to 8, and we can check it out, the proof, but the public JSON. What is the public output of our circuit with the inputs we have? Here, public output is 33. Yep, and we can just verify the whole circuit. So we're gonna use just verify verify proof example one, and here snark.js. Okay, this is correct, but if we try to edit something here, let's say public JSON, I'll try to edit that and we'll try if this really works. Let's try to make it 34 and okay, here error, invalid proof. This is the, because we have the public output and we have the proof, so that's how they check it. I think that explains all. That's how I learned, and I think if you try it out yourself as well, it's going to be really good learning experience. Thanks, Oscar, by the way. Oscar, the handbook, the tutorial itself is really good. I'll thank you for that.